Good evening, everyone. First of all, before starting today's class, I would like to congratulate all my ICSE and ISC students for doing an exceptional results. Now, again, I'm back with my chemistry classes and yet another video, and today I will be discussing on certain topics that I have promised in the previous class, where I have stopped. After that, today we will start with the electronic configuration. So today we will do first is shell distribution. So shell distribution, what is this shell distribution? As I have already told you, that this is my atom. So this is my atom. This is my nucleus, and these are the orbits on which the electrons, they basically rotate around the nucleus. Now, if this is the nucleus, then these are the orbits where the electrons rotate. And these particular orbits, they have certain names. The first one is K shell. The second one is L shell. Third one is M shell, and the fourth one N shell. Now you must be wondering that what are these shells? Just as I have told you that these are the shells on which the electrons rotate. Now you might be wondering that how many electrons in each shell can rotate. Yes, there is a limited capacity for that. For each and every of these shell, there is a certain capacity, and that is determined by the formula 2n square. So 2n square is basically the formula that is used for electron distribution. Used for electron distribution in the shells. Okay, so this is basically the formula that is used for the distribution of the electrons in the shells. Now let us say, for example, the first one is K shell, right? So for K shell, n is equals to 1. So when n is equals to 1, 2n square will be equal to 2 into 1 square, that is 2. So that means what? My K shell can accommodate only 2 electrons. Now the next shell, L shell, n is equals to 2. Now for this, 2n square is equal to 2 into 2 square, that is 4 into 2, that is 8. Right? Now going for the next one, that is M shell. Two into 3 whole square, that is 9 into 2, 18. So you can see that the K shell can hold 2 electrons, L shell can hold 8 electrons, and M shell can hold 18 electrons. But there is a small trick in this. Though M shell, it can accommodate 18 electrons, but when we will be accommodating the electrons over here in the M shell, we will do for only 8 electrons. The reason, if you ask me, it lies in the chapter of atomic structure in class 11. So it will be revealed in the class of atomic structure of class 11. So I'm not revealing it right now. But for the time being, you only know this much, that M shell, though it can accommodate 18 electrons, but it will only accommodate 8 electrons for you in class 10. So by this time, you all are now acquainted with this fact that electrons, they rotate around the nucleus, and inside the nucleus, as discussed in the last class, that there are protons and there are neutrons. Now one very interesting fact I would like to share with you people, that is, as you know, that protons are there inside the nucleus, but electrons are there in the outside orbits. They are rotating in the outside orbits. So one very interesting fact is that whenever some chemical reaction is taking place at that particular time, it is the electrons who take part in the chemical reaction, but not the protons. Let me tell you why. Because protons are there inside the nucleus, and the electrons which are there in the outermost shell, whichever shell of any element is the outermost, that shell is the one that participates in the chemical reaction. But not even the penultimate shell, that is the shell before the outermost. Even those electrons do not participate until and unless all the electrons in the outermost shell have participated. So this was one interesting fact that you can note down, that is, protons never participate in a chemical reaction. Hence, whenever there is any chemical reaction that is taking place, the number of protons do not change, but the number of electrons change. Now, why did I tell you this fact? There is a reason, obviously, and that reason I will be revealing you very soon. Now coming down to the concept of atomic number. So what is atomic number? Atomic number is nothing but it is the total number of protons that is there inside the nucleus of an atom. Okay? So atomic number is the total number of protons inside the nucleus of an atom, right? So now the number of protons and the number of electrons in an atom are similar. Okay, number of protons is always equal to number of electrons, or I can say number of positive charge is equal to number of negative charge. Now, one very important thing that I would like to highlight, number of positive charge is equal to number of negative charge. What does this mean? This means that they nullify each other. That means an atom is neutral. That is, it does not bear any charge. So this is another important fact, that an atom is neutral. Reason, I have already told you, that is number of protons is equal to number of electrons, or the number of positive charge is equal to number of negative charge. Now similarly, in an atomic number also, the number of atomic number is equal to, we can say atomic number is equal to number of protons is equal to number of electrons, right? Atomic number is equal to number of protons is equal to number of electrons. Okay, but there is a very important trick in this. In some of the board examinations, I have found this question, that they have asked that why an atomic number is determined by the number of protons. Can you just think for a moment that why is it so? Well, the answer is pretty simple, and I have already told you. That is, protons never participate in any chemical reaction. Hence, its number remains unchanged. But electrons, they participate in chemical reaction, and as I said, that the outermost electrons, they constantly, they either they move out of the atom, or they are added in. So the number of electrons, the total number of electrons, that constantly change. So that is the reason why the number of protons is basically used to determine the atomic number. Now coming down to the next concept, that is mass number. What is mass number? Mass number is equal to number of protons plus number of neutrons. So mass number is basically the number of protons plus the number of neutrons. Now let us take one example. Say for example sodium. So sodium has mass number 23, atomic number 11. So from this given data, I can find out how many protons and how many neutrons are there. Now as you know, this one is my atomic number and this one is my mass number, right? So if mass number is equals to number of protons plus number of neutrons, and also we know the fact that number of protons is equal to the atomic number. So we have the data atomic number over here. So from that we can find out number of neutrons. Number of neutrons is equal to mass number minus atomic number. So that is 23 minus 11, that comes to 12. So from this I can find out the number of neutrons. Now already, since atomic number is 11, so my number of protons is equal to 11. My number of neutrons is equal to, electrons. My number of electrons will be 11. So I have a complete data about if I'm given an element and if I'm given the mass number and atomic number. So I have a complete data about the number of protons, the number of electrons and the number of neutrons. What if I'm not given the atomic number? What if I'm only given the number of electrons or maybe the number of protons and I'm asked to find the number of neutrons? Well, I can always do that. That is, from mass number I can deduct the number of protons or the number of electrons and I can get the mass number, the number of neutrons. So here in this method, using this particular formula, I can solve any numerical based on this, right? And also I will be now showing you something, that is how you will be drawing the mass, the shell of an atom. Like say for example sodium. Let me name this as electron distribution in an atom. Let me take sodium. Sodium has 23, 11. So this is my mass number, this is my atomic number, right? So from here I have number of electrons is equal to 11. So how will I draw it? For that, now I will have to use the formula 2n square to find out the electron distribution. 2n square. So for n is equals to 1, it will be 2. For n equals to 2, it will be 8. But still I have one more. So for n equals to 3, I will have 18. But I don't need 18, right? I will accommodate. So this is for K shell, this is for L shell, this is for M shell. So in K shell I can accommodate 2 electrons. So in a L shell I can accommodate 8 electrons, right? And in M shell, the only one that is left, I will be giving that 1 electron. So let me draw it here. So here inside the nucleus, how many protons are there? Protons are 11. And how many neutrons are there? 12. That we have already found out from the previous your calculations. Now here is the first one. Let me draw the electrons with red. So first shell, that is the K shell, will have 2 electrons, right? Next is the L shell, will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the last one will have 1 electron. So that is my electronic configuration and electron shell diagram. Electron shell diagram of sodium atom. So here is my electron shell diagram of sodium atom. So today till this much. Thank you so much for joining my class, and till that time, in the next class, let me tell you, in the next class I will be introducing something different, that is the isotopes and the isobars and some fun related to it. So thank you for joining my class once again, and stay safe, stay happy, stay prepared. See you in my next class.